Let's start the class. So we have Vasundhara, we have Hiranya, Sanvita, Advik, Chandan, Suren, Dikshita and Araf. And now we have Jitesh as well. So let's start. What are we going to learn today? Shall we learn or we'll just do chit chat and disappear? What to do? Yadav. So like I said, you guys are taking my jokes also seriously at times. I said, shall we learn something? I will just do chit chat and disappear. No, we will learn here, okay? I am standing in my garage without AC with 90 degrees around me. I am not doing it for fun, for sure. So, let's get started. So, today we are going to learn about circles measurement. Now, you will say, I know circle. We know about perimeter of a circle, radius of a circle, diameter of a circle, how to find out area. What is there to learn more? And learning is a continuous process. So let's start. This is a circle. Does it look like a circle? It does? Okay. Now, who all remembers what is the perimeter of a circle? Yeah, tell me. So this is the radius of a circle. So perimeter is nothing but 2 pi r. And I'll say some simple, stupid things, bear with me. When I say perimeter, I'm talking about the length of the entire boundary from here all the way till here. So imagine this being my farming land. I'm talking about the length of the wire that I would need for barricading my land. Thankfully, I don't have a circular land, but if I had a circular land, the perimeter means the length of the quantity wire I would need for barricading my entire land. That's perimeter. Everybody with me? And I would request everybody to turn on the videos so that I don't end up becoming a robot in near future. Jitesh, Arav, Sanvita, Vasundhara, Advik, Hiranya. Yep. These are my kids. Very nice. Alright. So, perimeter, when we talk about, perimeter is nothing but the length of the entire boundary. And how you calculate perimeter is 2 times pi times r. R is nothing but the radius. Radius meaning the distance from the center to the any point on the perimeter. And I am repeating myself, I know it very well. But I am doing it for a reason. Okay? So perimeter is 2 pi r. Now, if you guys remember what is the area of a circle, not out of this time. Anybody else? Sanvita? Okay. Tell me. Everybody can say it together also, that's fine. Here, Rihan. Pi r square. Pi r square, right? And whoever could not say, okay, what happens is, the class before you guys, when I have younger kids, okay, I will ask a question, one child answers, and the second child says, I was about to say the same thing. As if somebody pulled the answer from his mouth. So it's okay. If not everybody could say, give the answer, that's fine. So this is just a recap. So we'll have more interesting things coming our way. So we are talking about calculation of circles, calculations related to circles. So the thing that we know is circle is a round shape where something is called center, and the property of the center is that the center is equidistant from any point on the perimeter or any point on the boundary. And when we say perimeter, perimeter is nothing but the length of the entire boundary which is the circle, or the length of the wire that I would need for barricading this land if this is mine. And area is nothing but is pi r square. And pi, as you all know, it's nothing but 22/7. It's a number given a name. Okay? And r is the radius. Now, when you say area, you are essentially talking about how big is my land, how much crop I can grow in this land. Yeah? If I have this smaller land, amount of crop that I can grow is much less compared to this one. Or in simple terms, the space that it takes. So these things you guys already know. All right. Let's pause for a minute.
Hello.
Yes, ma'am. You are?
Right.
Yep.
It's media. I'm media.
Oh, thank you for bringing the chair. Your name is? Gayatri. Have a seat. So, I don't have AC in the classroom, but I'm going to install it tomorrow. Don't worry about it.
Yep. Okay.
This will be fine.
Sure.
Yeah. Alright. So today, because of the climate, let's get some come. If you guys want to be here in the class, you are more than welcome. If you want to observe what
We can sit in the back seat.
that will be awesome. So, only thing is come over. Please be careful because of the wet floor.
No worries, we'll sit in the back. That should be fine. You please take care of the class.
You can take a chair. You can come.
No worries, please take care of the class. We will serve ours and that will be fine. I don't want to disturb your
Yeah,
class.
that is nice of you.
Thank you.
Yeah.
That should be fine. We will take care of ourselves. Please continue with the class.
So, leave that is right. I'm going to see that because of this. All right. So, Gayatri, welcome to the class, beta, okay? I have two daughters. One is in going to college this year, and one is in middle school. She is part of the class. She is not in the class today, but yeah, she joins here in the classroom. So, you'll not be alone here. Don't worry. All right. So, what we are learning today is about the measurements of circle. Okay. So, these are the things that you guys know. Perimeter of circle is 2 pi r. Be a little careful with the wet floor, okay? Make sure that you don't get hurt. Yeah. So, perimeter is 2 pi r and area of a circle is pi r square. And everybody must be thinking that this is something that we already know. Why are we teaching this? Because this is a building block which we will use for finding out area of a sector and a segment. Now the fun begins. What is the segment of a circle? Any idea? What is sector of a circle? Anybody? Any guess? Yes, Arab.
Like what fraction of the circle?
I have two questions. What is segment of a circle? What is sector of a circle?
Or the sector might be like the point that I don't know.
Okay, so I don't know what the right answer. You took 30 seconds extra and that will not get you any brownie point. Let's come to some meaningful thing. Okay, anybody wants to give it a shot? Without making a guess. Yadikshita.
For the sector, I think it's kind of like the vertex.
There is no vertex in circle. Everything is round, like my face. Yeah? Alright, Yaditika.
And then like a segment is like where there's like an arc as well, but like not even two radii, it's like four.
Okay. Yeah. No, you seem to have encountered with sector and segment. So I'll make it easy for everybody else to follow. I think one more child had raised the hand. Who was it? Was it Arihan? Yes, Arihan, go ahead.
Yeah, I was gonna say that one of them was kind of like a four.
Okay. Now let's look at this is a circle. Believe it to be a circle, even if it might not look like a perfect circle. So this is a circle. You know that this is my center. And the property of the center is this is equidistant from each and every point on the perimeter. That part you guys know. So if I connect from here to any point on the perimeter, this is nothing but the radius. Yeah? Now I picked up randomly 2 points. on the perimeter, this point and this point, and I join this. What did I do? I cut the circle into two parts. This is one part, the one in blue, and yeah, did I? I cut the circle into two parts, the one in blue and the one in red. So this red part or blue part, these are called sectors. I divided this whole circle into two parts by using these two radius. Right, Ritika? This was your definition too?
Yes.
So these are two sectors. So you can call this as a larger sector, smaller sector, or minor sector and major sector. So it boils down to the fact that if you have a circle and you pick up any two points and join the 2 points with the center of the circle, it splits the circle into two parts. The smaller part is called smaller sector, larger part is called larger sector. Is that digestible so far? Everybody with me? Okay. Now, I use two terms, sector and segment. So the same 2 points, if I join them with a straight line, again, forget about this guy. What did I do? I had 2 points in the perimeter, I just joined them. This is called segment. Same way, minor segment, major segment. So I split the circle again into 2 parts. So what is a sector? Sector is when you join the 2 points with the center, whole thing is sector. Segment is when you just join the 2 points directly. It splits into 2 parts. This is the minor segment, this is the major segment. Would you guys have any difficulty in relating to these two terms hereafter? Sector and segment, no confusion, right? No confusion? Okay. Now, life is not as interesting as you would want it to be. So, just telling what is sector and segment would not be enough mathematically. So what we will do is we will try to find out, if somebody says find out the area of a sector or a segment, let me give you guys some time to think about it, okay? I am saying I have 2 points in the perimeter which makes the angle 60 degree at the center. And the radius of the circle is, let's say, 10 centimeter. Find out the area of the minor sector. Ritika, you probably know it. I will pick you as my second option to hear the answer because I am pretty sure you know about it. Okay. Let's see, Sanita. So, if this is a situation, you have radius given, angle made by these 2 points in the center is given, and the question is, how do you find out the area of the minor sector? Sanita, tell me the approach. I am not interested in the answer right now. Tell me the approach first.
I have never really read this one. I've heard it before. I think you do like 60, then for like the angle of your sector divided by 360, and then multiply that by 5 times our squared.
That was a very mathematical answer and convincing enough. Let's hear it from Arav also. Yeah, Arav.
I was going to say, I can't see the radius because of the reflection of the light, so can you please say it again?
I said the same, I kind of repeated the question 2-3 times. I'll repeat one more time for you. I have a circle with radius 10 centimeter and I have 2 points in the perimeter which makes an angle of 60 degree on the center. Find out the area of the sector or the minor sector, whatever you call it. Now Ritika, try explaining that to me like you will explain it to a fifth grader.
I was gonna do like the same approach where you put like the central angle over like the total angle, so the total angle adds up to 360. So then the central angle in this case is 60, so then you put 60 over 360. And then you multiply it by pi r squared, and since r is 10, you can just calculate that.
Okay. Now let's see what Arihan has to say. Yeah, Arihan.
I would just do 1/6 times pi r squared.
Okay. Gayatri, any thought? Okay. So now, here's the thing. How I will approach this problem. And I'm pretty sure everybody has similar thoughts. Maybe I'm just narrating it differently. Now, if I look at any circle, any time, this makes an angle of 360 degrees. Correct? If I look at a circle, total angle of a circle, meaning from here all the way till here, I'm talking about 360 degrees. Correct? With me? Circle makes an angle of 360 degrees at the center. Correct? Total angle 360 degrees. Everybody with me? Now, so if I was talking about 360 degrees, then I was talking about the whole area. What I'm talking about? Only 60 degrees. Basically one slice of a pizza. Yeah? And how big is that slice? Depends on how big is my angle. If I am talking about an angle of 145 degrees, see my pizza slice became bigger. But here I am talking about 60 degrees only. Yeah? So, if it was total 360 degrees, I was talking about the whole area. I am talking about only 360 degrees. So, 360 degrees was the whole area. How much is area? Pi r square. How much is r? 10. 10 square. 360 degrees would have been the total area. I am talking about only 60 degrees. Only one slice of the whole pizza. So 360 degrees pi r square. 1 degree will be how much? Pi r square. 10 square is 100 by 360. Yeah? If 360 degree is giving you this much area, 1 degree will give you how much area? That is. Now, if my angle is how much? 60 degree. So 60 degree will be how much? 60 times of what is 1 degree value? That is pi into 100 by 360 into 60. Yep. Am I reaching everybody or am I teaching myself? Everybody? Sandrine, fill in with me. I'm sorry? Okay, one more time. If I had no plan like this, and this was a pizza to be eaten by Adrit, Adrit could have gotten the whole pizza, right? And whole pizza is how much? Total circle 360 degree. Correct? Adrit, are you with me? Okay. Now I am saying no, Adrit cannot eat the whole pizza. That is not good. Or that is probably way too big. I am saying that I will give Adrit a piece of the pizza which makes 60 degree angle at the center. How big a slice I am talking about? This slice would have been 360 degrees if the whole pizza was there. I am talking about 60 degree out of 360. So 60 out of 360 is what I am talking about. 60 out of 360 of what? Of the whole pizza. The area of the circle that the pizza makes. That is what I am talking about. Pi into r square is 100 into 60 by 360. Whichever way you understand. Either by this or by this. 60 of 360 or this method. Whichever resonates with you guys. I want to see some confused faces. Anybody? No? Disappointing. Okay, alright. So, clear, Vika? Make sense? Okay, so this is how you find out the area of the sector. So let me get you guys tired of this kind of problem. So tomorrow if somebody says, I have a circle, be it a circle in the form of pizza or a pie or a chapati, whatever it is. If I have a circle with radius of 15 centimeter and 2 points in the circle makes 30 degrees of the center, find out the area of the sector. You will always think this is 30 out of 360. 30 out of 360. Of what? Of the whole area. What is my area? Any circle can be described only with one parameter, one property, that is radius. If you just know the radius, you can draw a circle. Right? In case of a triangle, if I say draw a triangle and the side is 15 centimeters, you will say, we are talking about triangle, it has 3 sides. What about the 2 sides? But when we talk about circle, as soon as it gives you the radius, that is enough. You don't need anything else. Correct? Correct or not? Yeah? So, basically, if you are given a question that, okay, something is making an angle this on the center, find out the area of the sector, this is how you will look at it. You will say, okay, 30 out of the whole thing. Yes, Sandy and Sulaim, tell me better.
I feel like I didn't mean to raise my hand.
That's okay, it's okay to have questions, that's fine. Alright, so this part is understood. Now, the only flip or the twist that you might come across would be, make the angle 30 degrees, find out the area of the major sector. Then it gives you this angle, but you have to find out for this. So you can do it, say, okay, find out the area of this part, subtract that from the whole area, or you will say, okay, 350. 360 is the total angle, and this is 30 degrees. How much is this one? 360 minus 30. So 330 degrees. You will find out the area for 330 degrees. Yeah? So it's up to you guys how you visualize this and then try something. Yeah? Now, many of my kids say that I am not a good teacher. And there is a reason for it. Yeah? Because I will not let you guys relax. Now you guys figured out how to find out the area of a sector. So these are the 2 points making 60 degrees on the center, let's say. I am again thinking of 60 degrees. Radius is given as 30, let's say 20 centimeters. I know that you guys have learned how to find out the area of a sector. I am saying no. I want you guys to tell me the area of a segment. Meaning, I am talking about this area. Tell me, how will you find? Think of the approach, okay? I am only interested in the approach. How part will figure it out. I mean, calculation will figure it out. Yes, Ritika.
So you know how to find the area of the actual sector?
Mhm.
Because you can draw like the line in the triangle. And you can find the area of the triangle and you can subtract it. You can do the area of the sector minus the area of the triangle and get the area of the circle.
Ritika has dealt with it enough. So, did you guys understand what Ritika said? You did not hear it properly. Okay. So, don't try solving this problem with a math. Let's use common sense. What we have is that, okay, fine, the radius of the circle is 30 centimeters and there are 2 points in the perimeter which is making this angle 60 degrees here. Okay? And I am saying, so these are 2 points, let's say this is A and this is B. And let's say O is my center. So point A and B is making angle 60 degrees of the center. I am saying, I want to find out this area, this shaded area. So what Ritika was saying was that by now we have learned how to find out the area of a sector, meaning area of this circle, this triangle plus this part all together. We know the area of the whole thing. From that, if we remove the area of this triangle, then so basically let's say area of whole thing. O, A, B. Let me pick a point B here so that you guys don't get confused. OABD, meaning the whole thing is my area of sector, minus if we take the area of the triangle OAB. From this whole thing, which includes this curved part as well, which is my total area of the sector, from that if I subtract this triangle's area, then whatever is remaining is my this area. Correct? Visually. One more time. One more time. So, now some of the kids will start making noise because I'll repeat myself. There is a story that I tell every kid in the first class. So guys, this is your first class, so I'm telling a story. If I'm a runner, how will I perform in the tournament will depend on how well I ran in the race. Right? How well I ran in the race. Yeah? Whether I'll get a gold medal or a silver medal or bronze medal in the race will depend on how well I ran. Now what is that ran? R stands for reading the question again and again. When you have a problem to solve, read the question once, twice, 3, 4 times till you are tired or till you think that I have learned everything about the question. Then you start analyzing it. Analyze, you start thinking, okay, this is the question, this is what it is asking. This would be my approach. You have still not touched the pen. If you touch, you just use for drawing or doing some scratch work, not for solving the problem. You read the question, then you did the analysis, and you are clear with your blueprint that this is how I'm going to solve it. Then you go to N. N stands for Nike, the shoe that your brother is wearing right now. What does Nike say? Just do it. This is when you start doing the problem. Read the question enough, analyze the problem or analyze the approach, create a blueprint, and then you try solving it. Where you go wrong, you got a question, you start solving it. That is where you might take the wrong approach, and then you will end up doing a couple of times and waste a lot of time. But if you follow this approach, read the question a couple of times, you are very clear about the question, then you put your thoughts together, then you try doing it. That is what Advik and Arav have learned or heard at least 100 times by now, and everybody else probably 10, 15 times. But it doesn't do any harm because I'm re-emphasizing that whenever you are solving a problem, don't rush for solving it, because if you rush, that doesn't guarantee you the right answer. Okay? When you spend your time, read the question enough, analyze, and then you try doing it, your chances of doing it right is more. Yeah? Now, so again, going back to the same thing. The question was, this is a circle, and I said there are 2 points in the perimeter which is making an angle of 60 degrees on the center. Find out the area of the segment. So, by now we have learned how to find out the area of a sector. Area of a sector, meaning red and blue together we have learned how to find it out. But this time we are talking about finding out the area of the blue part alone. So we know red plus blue how much it is, or how to calculate. So once we find that out, and then from that if I delete the red part, then I will get the area of the segment. Right? That is what we are trying to find. That's what Ritika explained. That okay, if I have the situation like this, I have to find out the area of this segment. By now we have learned how to find out the area of red plus blue together. Red plus blue. We know from this, if I minus the area of the red part, what I will be left with will be the blue part, and that is what is my area of the segment. Yeah. Now, how do we find out? We will see if we are able to solve it, or I need to borrow some intelligence from my neighbors, but we'll figure it out. Yeah? Okay. My neighbors are much more intelligent than me, that's why sometimes I end up borrowing some intelligence from them. But the serious message for you guys is, when you are trying to solve the problem, you might not be able to solve everything by yourself. Come up with your approach, some of the things you can always borrow, share from your friends and then try doing it. Now here I see that now kids don't ask questions, don't share with their friends. When you share, trust me, you are the one who gets benefited the most. Okay? So don't be shy. When you learn something interesting, share with your friends. Say, I learned something new. I want to just let you know. Or if you are struggling with some problem, catch hold of your best friend. Say, okay, fine. I'm trying to deal with this problem. I'm not going to get the clue. You know how to solve it. Doesn't do any harm. Okay? Do it like a sport. So now we have come to a point that where we have an approach. We read the question enough. We read the question enough. And we also did the analysis. Right? We said, okay, fine. We know that this is making angle 60 degree. So when I'm doing my analysis, we figured out, okay, fine. We know how to find out the total area. If I'm somehow able to find out what is the area of this guy, I will just minus this. That will give me this area that I'm looking for. So my reading part is done, analysis is done. Now comes and the Nike, first letter of Nike. Now if I figure out how do I get this area, then I will find out the total area minus the area of the triangle and then try solving it. Let's do it now. So, same problem, let's try solving it. This is 60 degree. This is OAB. And the radius is, let's say, 20 centimeter. Area of sector, I am solving it for you guys. And then when I give you guys some assignment, then you'll be able to practice it as well. Don't worry. So area of the sector is area of sector. Okay, I'll write it in simple English always, so that I don't get confused when I'm reviewing what I did. Area of sector is nothing but 60 out of 360, right? Of the total area, which is pi into r square. R square is 20 square. So that means 60 into pi into 20 square is 400 divided by 360. 1010 gone. 60, 10 6 are 60, 6 10 are 60, 6 6 are 36. So what I have is 14 to 10, 400 pi by 6. I'm just keeping it here, okay, for now. This is my area of the whole thing. Now my biggest problem is to find out the area of this triangle. Now you look at this triangle. What do you see here? How would you find out the area of this triangle? What are the things that we are aware of? We know that this is the radius 20, so this is also radius 20 centimeters. How would you find out the area of this guy? This is an isosceles triangle, correct? Or maybe an equilateral triangle. Why? Because this is 60 degrees. Now these two sides are same. So if the two sides are same, that means the angle will be the same. If this is x, this is also x. So 60 plus x is how much? 180. So 60 degree plus x is 2x is 180 degree. Who all is getting stressed out? Nobody? At least one. I want somebody to start scratching his or her head. That gives me a lot of happiness. Now, okay, jokes apart. Coming here. So now, this gives me 2x equal to 60 goes that side, 180 minus 60, which is 120. 2x is equal to 120, x equals 120 divided by 2, which is 60. So this means this is 60 and this is also 60. Yeah? And again, remember this. I am not trying to act very smart when I am doing this whole calculation. And I am trying to do one thing is, keep this like a story. Step by step, right? I'm saying this is a triangle, this is 60 degree, this will be x and x. X plus x plus x. All together is 180. Then I'm doing the calculation, I'm doing step by step, so that if I go wrong anywhere, I would be able to review it and figure out where I went wrong. Yeah? Yes or no? So I keep on saying this again and again, right? That I would always want you guys to, whenever you're doing calculation, make sure that you're doing step by step, so that it's easy for you to review. Because during the exam, outside the examination hall, you have time to do as many iterations you want. But in the exam where you are hard pressed for time, and then you are not able to figure out where you might have gone wrong, you are not written the steps in the scratchbook, it becomes very difficult to figure out where you might be wrong. Okay? So now we have found out that okay, it's an equilateral triangle. That means all the three sides are same. But that is still not enough to find out the area of this guy. Because area of any triangle is nothing but area of any triangle is half into base times height. Correct? If I take this as a base, I don't know how much is this one. Oh, now I know. Now actually I know. Because this is 60, this is 60, this is 60. That means it's equilateral triangle. So this length is also same as R, radius, 20 centimeters. Making sense? No, it's okay. I mean, you don't have to say yes, okay? I might be rushing when I'm explaining things, okay? So, see, what did we do? We know this angle is 60 degrees. This was given to us. If this is 60, these two angles have to be the same because the two sides are same. Both are radius, right? So, and when these two sides are same, that means sum of this angle and this angle is 120 because this is 60 already gone here. 120, and since the sides are same, the angles will be the same. So that is how we found out the angle, both the angles are 60 degrees. So now, when this is all 60 degrees, that is an equilateral triangle. Then equilateral triangle meaning third side will be the same as the two sides. So this is 20, this is 20, this will also be 20. Now, half of the problem is solved. We know base is okay, base is 20, wonderful. But we don't know the height yet. How will I find out the height of this triangle? Everybody is feeling sleepy now. It's too early. Yes, Nitika.
Yes, so you're asking like how to find out like the height. So you can draw like a straight line.
Perpendicular from here to here.
Yeah, and then it will create like a 30, 60, 90 triangle.
Yes.
And then for the rules of a 30, 60, 90 triangle, like the one across the 30-degree angle is half the hypotenuse, so you'll get 10 and 10 for the bottom. And then for the height, which is the height, you'll get a 10 degree.
Okay, so that might be a little bit of an overdose for some of you. Ritika probably has dealt with this, but let's simplify this. Okay? Let's simplify this, and we will come back to this today again tomorrow. Okay, I know this is not an easy concept, so we have to relate things. Okay, so now let's look at the same thing again. We are trying to find out the area of this triangle where this angle is 60 degree. This will also be 60 degree. Because if this is 60, the remaining part of the remaining two angles, which is 120, are both equal because this is isosceles triangle, right? So this became, these two sides are same, so these two angles have to be same. And eventually it became an equilateral triangle, all sides same. So this is 20, this is 20, and this is also 20. So for finding the area of this triangle, we know that it has to be half into base into height. We found out this base. We don't know this length. This height we don't know. How do we find out that height is what Ritika was saying. So Am I going too fast or you guys are with me? Sanvita, Arihan, Gitesh. Yep, yeah, Arihan, go ahead.
Since it's a right triangle, we could, since we already have the hypotenuse and technically the base, which is 10 for each of the small triangles,
Yeah.
we could figure out how to find the height.
Right. So now, this is first class for Gayatri. So Gayatri, do you know what is a Pythagorean theorem? No? Okay. So I'll have to spend 2 minutes explaining that. So, Pythagorean theorem is a theorem which says if I have, this is a right angle triangle, right? This is 90 degrees. Yeah? And you don't have to take notes because everything that I'm doing recorded here. I will upload this for you which you can use for review later. So this is a right angle triangle. Let's say this is side A and this is side B. These two sides together are making this 90 degrees. And this is called right angle triangle. This is called hypotenuse. In a right angle triangle, when your one angle is 90 degrees, these two sides are making 90 and the side opposite to that is called hypotenuse. So what Pythagorean theorem says is, if you have a right angle triangle, then the two sides which are making 90 degrees, if you take square of both the sides and add them together, that will be equal to the square of the third side. Okay? So in simple terms, Pythagorean theorem says that in a right angle triangle, the two sides which are making 90 degrees, if you take the square of both of them and add them together, that will be equal to the square of the third side, which is the largest side. This is Pythagorean theorem, and for now you will memorize this because we don't have a choice right now. It's a Pythagorean theorem, but I have also explained how this theorem is derived. Okay? And we'll keep on learning those things. We'll come back to those things again. But here, what Arihan was saying was that if you have a triangle like this and equilateral triangle, if you drop a perpendicular from here to here, meaning make a 90 degrees here, then this line divides this whole thing into two parts. And yes, Arihan.
Wait, I have a question. How can you assume that that triangle is an equilateral?
One more time.
How can you assume that triangle is an equilateral?
I don't think I could hear your question. One more time.
Wait, how would you assume that it's an equilateral triangle?
Zoom inside an equilateral triangle.
Yeah.
You have to repeat your question, Arihan. I don't think I am able to follow you. Like I always say, I am not very intelligent. Say it one more time.
Like, how could you assume that triangle is an equilateral?
Oh, how I am assuming that this triangle is equilateral triangle? No, I am not assuming. I would never dare to assume. Math is something that you cannot cheat. If I ever assume, I will be proven wrong. Now look at this. What did I say? This question was saying that this angle is 60 degrees. Okay? This angle is 60 degrees. How much is this angle and this angle? Tell me. These two angles will be same for sure because this side and this side are same. Right? For now, don't assume that this is an equilateral triangle. Okay? Don't assume that. That will be a crime. But you can for sure assume that these two sides are same because both are radius of the circle. Now, if the two sides are same, then the corresponding angles will also be same. Right? If the two, this is isosceles triangle, then these two sides are same, these two angles will be same. Forget about this angle for now. these two angles will be same, right, Arihan?
Yeah.
Yeah. So now if these two angles are same, let's say this is x and this is also x. So x plus 60. X plus 60 is 180 degree. Agreed? Now x plus x, 1 banana plus 1 banana, 2 banana, plus 60 is 180 degree. That means 2 banana equal to 180 minus 60 degree. Yep. That is 2x equal to 120 degree. X equal to 120 divided by 2. This comes down. This becomes 60 degree. So wherever I had x, I have put replacing that with 60 degree. Now you tell me what exactly it is. Equilateral triangle or not?
Yeah.
Yep. So that's what I'm saying. So your question was valid. You were probably not convinced why it is equilateral triangle. So I'm just telling you guys how it is equilateral triangle. So let's check the time. I don't want to give you guys a lot of information and then get you confused. Understanding area of sector and area of a segment is not very easy thing. Calculation wise or understanding wise. It helps you, it requires you to understand a little bit of geometry, a little bit of trigonometry and a little bit of common sense. Okay, so we'll use all the three. Trigonometry you would have not dealt with before, right? Okay, so we will try to avoid trigonometry part, we'll try solving this with geometry alone. But for now, whatever be the case, we are trying to find out the area of this triangle. So interestingly, in this case, this angle was 60 degrees, so it became an equilateral triangle. But regardless of that, we have to find out the area of this one. So we have to find out the base and the height. That is the only way we can find out the area of a triangle. Half into base into height. In this problem, we found this is the base, same as the radius, because it turned out to be equilateral triangle, right? So we found half into base. Base is 20 centimeters. What we don't know is the height. This height. I think Ritika is clear about it. Arihan also has some idea about it. But I don't want to tell you guys how to find out this height in next 10 minutes. That will be too quick to digest and process. So let me hear your approach. I want to hear what are the different approaches that you can apply to find out this height. Let's think about it. Yeah, Gitesh, tell me what would be your approach to find out this height? How did you find out that the base is 10? But how half? How did it divide into half? I will peel off all the onions skin, okay? So when I'm peeling off, I'm making you think, okay? That's why I'm asking the question, okay? I'm not putting anybody on the spot. I'm trying to see how clear, how confident are you. If I say I have an equilateral triangle and if I drop a perpendicular from here to here, it divides into half. I agree, this divides into half. But how? Yeah, Dikshita.
We split the triangle and then like we see which is like, is it like the right angle triangle, and since the right angle triangle is like 90 degrees, we do like the slightly like minus like half like the corner short, we minus them and get like something.
You are thinking in the right direction, but as I said, I'll make sure that I peel off all the onions to get to the actual content. Yes, Arihan, tell me.
Since the line is in the point, the top point of the triangle, and since the point of the triangle is in the middle of the circle, that means if it wasn't on the corner plate, then it wouldn't be a half. So since it's in the point.
No, I'm going one level further. Let's debate this one. Let's break this into smaller pieces because these are interesting concepts, okay? And we have a lot of time to waste also, right? You guys have no exam, you just finished your school year. So even if you spend one class debating about this one to get our concept right, let's do that right away. So let's forget about the circle for a little bit. I'll come to you. So I have an equilateral triangle. I will make sure that after today you guys have no doubt about it. It's equilateral triangle, meaning this side, and this side are same. Okay? And other thing that we know is this is 60 degree, this is 60 degree, this is 60 degree. This is the property of equilateral triangle. If I drop a perpendicular from this vertex to the opposite side, if I drop a perpendicular, meaning this angle is 90 degree and this angle is also 90 degree. Okay? Then this perpendicular that I am dropping here splits this triangle into two equal parts. This side into two equal parts. If this was 20, then this becomes 10 and this becomes 10. I am not denying that. I want to know on what basis you guys are thinking that it will be 10, 10. Yes, Ritika.
So when you drop like the height, so we know that the two angles are 60 and 90. So then all the angles in the triangle add up to 90. So the remaining angle would be 30. So since it's 30 on both sides, it splits the angle into two. So this is 50.
So what you are saying is, when I drop a perpendicular from here to here, this is 90 and 60, so this has to be 30 degree. This is A, B, C, and this is D. So when I am looking at angle DAC will be equal to 30 degree because this is 90 and this is 60. 90 plus 60, 150 plus 30 will make it 180. So this is 30 degree and this will be the same case here also. So angle DAB will also be 30 degree. I agree now. So the angles are 30 degree. That's fine, understood. But that still doesn't convince me that this and this will be same. Yes, Deepika.
What we can do is like the properties of the 30, 60, 90 triangle to find out the triangle.
So that is trigonometry. I am not going for trigonometry. Still I am trying to prove that. How will I do that? There is something called theorem of congruence. Do you guys remember now? What are those theorems? There are four theorems. S, 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 A, S, A, S, A, R, H, S. So, okay. What is congruence? Yeah, Dishita.
Oh, when we like do like a shape, it has to be like the exact same.
My hands are congruent. Okay? If my hands were deformed, one hand was bigger, one hand was smaller, then it cannot overlay each other. So when you talk about two shapes being congruent, then you are saying that they are exactly the same. Meaning all sides are matching. This side matching, this side matching, this side matching. This angle matching, this angle matching, this angle matching. And the area of the triangle and the area of this triangle will also be the same. So basically when you say two things are congruent, let's say that your house and my house is congruent. What does it mean? They have exactly same properties. Okay? That's what congruence means. So here, in this case, these are four theorems. which says you don't have to look at each and every property of two triangles to say whether they are same or not. You can use some of the properties. One is SSS, meaning if you have two triangles, let's say this is one triangle, this is another triangle. If the sides, this one side of this are matching, second side and second side matching, third side is matching, then you can assume that they will be congruent. Meaning the area will be same, the angles will match. You don't have to look at each and every property. Okay? So this is the first theorem. And how that theorem came into existence, we have proved that in the previous class. We'll do it one more time. So we are starting this whole syllabus afresh from next week. So don't worry about it. Okay? Anything new that you come across, don't get stressed out. This class is, I say this is the class for my kids. Everybody is my kid here. Okay? Don't be afraid, don't be shy. Don't think that, okay, if I say something that is wrong, who will think what? Nobody thinks here. We are all here to learn something. That's all. So don't even worry about it. But coming back to this one, this is one theorem, SSS. Meaning, if I have two triangles where the three sides match, I can assume that they are congruent. Second option is SAS, meaning if two sides, this side match, this side match, and the angle between the side, angle, side. So S stands for side, A stands for angle. SSS, all three sides match, wonderful, they are congruent. Two sides and the angle between them match, they are congruent. We are not looking at everything else. If two angles and the side between them match, meaning let's say this angle. So this angle and this angle match, this angle and this angle match, and the side between them match, then they are congruent. This is the third theorem. This is an outlier. This is only for right angle triangle. R stands for right angle triangle and says if the hypotenuse and one of the side match, RHS. So now you look at these two triangles. Both are right angle triangles. Now hypotenuse, this one and this one is anyways matching, and this side is anyways common. That means they are congruent. They are exactly the same. Meaning remaining properties will also match. Now this side and this side will also match. The whole thing was 20. These two are matching. It becomes 10. Now if you tell that story like that, that would have made me more convinced. Everybody is shaking head, but I am not confident. Everybody confident? Everybody clear? Ritika, you were telling me the trigonometry approach, I told you the geometry approach. And now the class has two options, trigonometry versus geometry, depending on whatever you feel comfortable, whatever you are able to recall when you are doing the problem actually while solving the things. Yeah? So with that being said, I will probably stop here. I will let you guys go because I am very happy that we did not solve this problem today. And I am not in a hurry to solve this problem because it is putting a lot of concepts together. So we were just breaking it down. First of all, we looked at the area of the sector. How do I take the sector, area of the sector and minus the area of triangle to get the area of segment. Now how do I find the area of triangle first place? That is what we are trying to relate. So there are a lot of concepts, lot of stressful things, but the way I am playing right now, I would want you guys to play with it. So that is why we are disintegrating them into smaller pieces so that when you have to solve it, we'll be able to do it by ourselves. Yeah. So we'll continue with this problem. This is basically, if you look at the syllabus, right? In geometry, this itself is one big chapter, and we never finish one chapter in a class. So no hurry, no worries. We'll come back to this problem tomorrow, same time. Whatever we learned, whatever we got confused with, we'll carry it forward to the next class and see if we are able to break it down. Yep. Alright. With that being said, I'll let you guys go. Enjoy the rest of your evening. See you guys tomorrow, same time.
Thanks,
Alright. Bye bye. Take care.